So today I'm going to talk about finding the area between two curves. This is page 635 in your notes. And so finding the area between two curves is actually a pretty straightforward process. It's really easy to see graphically. You do have to know what functions look like. If this is on the non-calculator portion, you do have to know what these functions look like in order to figure out, okay, which one is the top function and which one is the bottom. But let's just jump in. So it says graph the function f of x is equal to negative 1/2 x squared minus 2x plus 4 and find the value of the integral from negative 5 to 0 of f of x. Okay, so if you have your graphing calculator, you can sketch a graph of the function, and you will find that the vertex of this is a parabola, okay, and it's an upside down parabola because of that negative 1/2, okay, and so using your calculator you can find that the vertex is located at negative 2,6, which is about right there, okay, and then you can find some other points. I do know that the y-intercept is at 0,4 because of that term right there. Because a parabola is symmetric, I know that there's going to be a point there as well. I can also use a calculator to find the zeros, which end up being right there. Okay, so this is just a rough sketch of this function. Okay, so it looks like that. So it says using one color, shade the region for which this value represents the area. So we're looking from negative 5 to 0. Okay, so we're looking from here to here. Okay, and so we look at this area. Okay, now to find this integral from negative 5 to 0 of negative 1/2 x squared minus 2x plus 4 dx. Okay, now you could use your calculator if you really wanted to. Actually, let's just go ahead and do that. Because we used our calculator to sketch the graph, let's assume that we have our calculator with us. So if you evaluate that integral, you will get that it is 24.167. Okay. Now, let me go to the next slide here. On the same grid, you're gonna graph that g of x, okay? And I actually have this shaded wrong. So let me fix the shading here. Okay, so it only goes from negative 5 to 0, which is this. So I think that's what I had on the last slide. So using a different color, we're going to graph g of x, which is 1/2 x plus 4. So I know that it hits the the y-axis at 4, right there. And I know that the slope is 1/2. So I can start to sketch a graph. Okay, and so this function is going to look like this. So this is g of x. Now, using a different color, you need to shade where this integral is. So from negative 5 to 0. So you're looking at all of this right here. Okay, so again, we can figure out the integral. So from negative 5 to 0 of g of x, using your calculator, you will find that it is 13.75. Okay? Now, what do you suppose you would do to find the area of the region that is located in between the graphs of f of x and g of x? So you're actually looking for this area right here. Okay, the area between the two graphs. Well, it's kind of a straightforward answer. You're going to subtract the area shaded in red by the area shaded in purple to get the blue. Okay, so you're actually going to subtract the integral from -5 to 0 of f of x, that's the top function here, minus the integral from -5 to 0 of g of x. And that should give you the area in blue. So you always subtract top minus bottom. Okay, whichever one is the top function and whichever one is the bottom function. Okay, we can also use properties of integrals to rewrite this as the integral from -5 to 0 of f of x minus g of x dx. Okay, and shame on me, I didn't put the dx over here. Okay, this is a general form of how to find area between two curves. Okay, so flip the page. So now find the value of the definite integral below if f of x is equal to our parabola and g of x is equal to our line. Okay, so to find this integral, we can say that from -5 to 0, well, f of x is -1/2 x squared minus 2x plus 4 minus g of x, which is 1/2 x plus 4, and all of this is dx. Okay, so let's try this without a calculator. Let's do some simplification. So this integral simplifies to -1/2 x squared minus 5/2 x, and then the 4's, they cancel. So this is dx. Okay, I know you guys don't like fractions. That's okay. We're going to have to deal with it. Okay, so if I take the antiderivative of this, I will get -1/2 x to the third over 3 minus 5/2 x squared over 2 evaluated from -5 to 0. So clean that up a little bit. I get x cubed over 6 minus 5x squared over 4 evaluated from -5 to 0. Okay. Now if I plug in 0 in for x, I just get 0 for the first one. So remember, it's top minus bottom, so minus, and then I plug in -5 in for x. Okay. Now, I guess you can use your calculator for this, because those are kind of funky fractions. You will get that it is 10.417. Okay, so this right here, you just found the area between these two curves. You found this shaded region right here. Okay, now you can actually take these integrals separately and subtract them, and you'll actually get the same answer. So if we take the integral from -5 to 0 of f of x dx minus the integral from -5 to 0 of g of x dx, well, we calculated the first one to be 24.167 minus, and you can actually find out, or no, we did find it. It's 13.75. That's this integral right here from -5 to 0 of g of x. And you'll actually find that it does equal the 10.4, what was it, 17? Okay. So that just kind of proves what I'm talking about. So in general, we find the area between two curves. So area between two curves is equal to the integral from a to b of f of x minus g of x dx. So where x equals a and x equals b, those are the intersection points between the two curves, okay? Are points of intersection between the curves, okay, and where f of x is bigger than g of x. That just means that f of x is the top function and g of x is the bottom function, okay? If g of x was the top function, then you would just flip it, okay? It is always top minus bottom. Okay? Let's move on. So knowing this, we can find the area of the shaded region R, okay? This is where you have to know what these functions look like, okay? You have to figure out which one is on top and which one is on bottom. Okay, so we have sine of pi x and x cubed minus 4x. Now, which of those is the top function, okay? Well, this function right here, because I know what sine looks like, I know that that is the sine function, okay? Sine of 0 is 0. Sine of 1 pi is 0, okay? So this function, that is the top function, which means that is the bottom function. Okay? So to find this shaded region here, we have to find the integral. Now, we need the intersection points. So our first intersection point is right there. Okay, so well, that's the x value 0. Our second one is over here, which is 2. So the integral is going from 0 to 2 of the top minus bottom. So we're going to have sine of pi x minus x cubed minus 4x dx. Now, please put parentheses around that second function. Otherwise, distribute your negative accordingly. So, if we try to integrate this, well, sine of pi x, you should recognize that as a u substitution, okay? So, if we have u is going to equal pi x, then du is just going to equal pi dx, right? So, our new integral for this little chunk here is going to go from 0 to 2 sine of u du. Now you can always separate these integrals, so minus 0 to 2 x cubed minus 4x dx, okay? And that's okay. So whenever we integrate this, you should get negative 1 over pi cosine of u, which I'm just going to substitute as pi x, evaluated from 0 to 2, minus x to the 4th over 4 minus 2x squared. Again, evaluated from 0 to 2. Okay. I want you to try not to use your calculator on this. Again, there are portions of the AP test where you cannot use a calculator on these. Okay, so if I plug in 2 in for x for this cosine here, well, I will have negative 1 over pi cosine of 2 pi minus negative 1 over pi cosine of 0. Okay, Well, that will evaluate to, so cosine of 2 pi is 1, so I have negative 1 over pi minus cosine of 0 is still 1, so minus negative 1 over pi. Well, those just cross each other out and you get 0. Okay, so then let's evaluate this other one here. So minus 2 to the 4th over 4 minus 2 squared, and then minus 0, because if I plug in 0 in for x, that's what I'll get, is just 0 across the board. Okay, so 2 to the 4th, what is that, 16? So 16 over 4 minus 2 times 2 is 8, or 2 times 2 is 4, times 2 is 8. Okay, and remember this is minus in front. So I have negative 4 minus 8, which ends up being positive 4. So all of this area here is 4. Okay, so at this point, if you want to take a break and maybe try a couple of these on your own, I would suggest that you do. If you don't think you can, let's just keep moving. Okay, so this is on page 637. So it says, pictured to the right is the graph of f of x is equal to, oh man, that cubic function there, and a line L, which is tangent to f of x at point 0,3. So it says, find the area of region R. So R is this part right here. Okay, now, this is not an area between two curves. It's just finding the area of one curve, okay? You do need to figure out this point right here. Okay, so if you, this is the graph of f of x, okay, and this is line L. Well, line L plays no part in this area here. So you need to figure out, where does f of x equal 0? So if you plug in this function into your calculator, use the 0 function, you will get that that x value right there is negative 1.373122. Okay, so to find the area of region R, we're going to go from that x value, let me make that a little smaller, so from negative 1.373122 all the way to 0, and we're looking at f of x. This is definitely a calculator portion, okay? So if you punch that into your calculator, you should get 2.90309. Okay, and that is the area of region R. So now it asks, find the equation of line L if it is tangent to the graph of f of x at 0,3. So all this is asking for is the equation of the tangent line. Okay, well for that we know we need two things. We need the point of tangency, which we have in 0,3, and we need the slope of the tangent. Okay, for that we need the derivative. So if f of x is equal to this ugly thing here, minus x squared okay, I need to find the derivative. Okay, well that's going to be 3/4 x squared minus 2/3 x minus 1/2 plus, sorry, no, minus minus 3 sine x. Okay, now we plug in the x value of our point of tangency in for x. So we have f prime of 0. Well, that's going to knock off that one, that one. I have negative 1/2, and sine of 0 is 0. Okay, so f prime at 0 is just negative 1/2. So the equation is going to be y minus y1, which is 3, is equal to the slope, x minus 0. Okay, if you really wanted to, you could simplify it to negative 1/2 x plus 3, but that's not necessary. Okay, so at what ordered pair other than 0, 3 does the graph of line L intersect the graph of f of x? So we have this point right here. That's the point of tangency. They want to know at what other point does it intersect f of x. So they want to know that point right there. Okay. So if you have a calculator, you can plug in both of those equations into your graph and use the intersection function. Okay. If you have no idea what I'm talking about, ask me during class. Okay. And you should get that the point of intersection is 3.3898677 and 1.30506662. Okay. So those are crucial points because that will help us find the area of region S, which is our next question here. So now we need to find all of this area. Again, it goes from intersection point to intersection point. Okay, so remember it's top minus bottom. So this is your top function, which is y equals negative 1/2 x plus 3, and this is f of x. So to find the area of region S, you're going to take the integral. So you're going to start at the first intersection point, which is 0, and then the next x value, which is 3.3898677. Okay, and you remember it's top minus bottom, so it's negative 1/2 x plus 3 minus f of x. I don't want to write out that whole thing again. Okay, but if you punch that into your calculator, you should get 6.982. Okay, well, does this value make sense? Well, what was the area of region R? Okay, R, if we look back a couple of slides, ended up being 2.90 something something. Okay, region S is significantly larger. Okay, 6.9 something. So that kind of makes sense in the context of our problem. Okay, now I encourage you to pause the video here and try to do page 638 by yourself. Okay. Okay, so I hope you tried this on your own. If you didn't, well, I guess it's okay. So picture to the right are regions R and S, which are formed by the graphs of f of x and g of x. Now, assume that we have a calculator on this. Okay, so using your calculator, if you punch in those functions, you will see that this function here, that is f of x, and that one there, that is g of x. Okay. Now, it says identify the points of intersection of f of x and g of x. So we need 2 points. We need that guy right there and that one there. Using your calculator in the intersection function, okay, let's just say that that is AB and this is CD. So the coordinate AB from your calculator is 0.17822 and 0.78109. Okay, I take as many decimals as I can to avoid any rounding error. And then we have the point CD, which is nice and easy. It's 1 and 0.25. So using this, these points of intersection, find the area of region R. So region R here, which one is the top function? Well, the top function is g of x. Okay, so our integral is going to be g of x minus f of x. Okay, and which x values are we looking between? Well, this is 0, and this first x value here is a. So we're going to go from 0 to a, well, a is our 0.17822. Okay, so if you punch that into your calculator, you should get 0.065. Okay, now it asks find the area of region S. Okay, well, S is between A and C. Okay, so our integral is going to go from A to C, and now we need to figure out, okay, which one is on top and which one is on bottom. Well, that's f of x, so it's going to be f of x minus g of x. Okay, so again, punch that into your calculator, and you should get 0.410. Okay, so these areas aren't very big, but does this make sense? Is the area of S bigger than the area of R? Well, R was 0.065, S is 0.410. Yes, it is bigger. Now, the next question, find the area of the unshaded region bounded by the graphs of F, G, and the x-axis. So what it's looking for is all of this right here. Okay, now this can get kind of tricky, okay, because you have to take it in pieces. So I'm going to break it up at the intersection points. Okay, and we want that area there. So my first integral is going to be this chunk here. Well, that integral is from 0 to the a value, whatever that was. Okay, and it's going to be the area under the curve of f of x. Okay, then I'm going to add to it this chunk here. Well, the integral is going to go from a to c, and that is going to be using the function g of x dx. Okay, and then this last little bit here, we need to go from C, and we actually need to figure out what that point is there. Okay, so using your calculator, you can actually figure out what the 0 is of that, and so it ends up being 1.08043306. Okay, so okay, and that is going to be using the function f of x. Okay, now if you're really good on your calculator, you can get an exact answer without having to round it all. If you're curious about what that looks like, you can ask me in class, but you end up getting 0.486. And that is your answer for the area that is bounded by F, G, and the x-axis. Okay, so if you guys have any questions, let me know. I will be checking your notes on Monday of, Monday the 8th. However, Thursday, which is the 4th, you will have an exit ticket over this stuff. The exit ticket is going to be worth a quiz grade, so I highly recommend that you are watching this before Thursday. Okay, like I said, if you have any questions, let me know.